Hello, I would like to explain you some ideas I had lately about how to name the various concepts about how XOR and ECC are working together. So at first I had the idea that there are the two concepts, either we do XOR first and afterwards we do ECC, or we do ECC first and afterwards we do XOR. That was the first idea. Unfortunately, it depends heavily on the perspective. So from the writing perspective, if you take a look at this example, we would first do XOR and afterwards do ECC, so that would be ECC after XOR. But from the reading perspective, it's exactly the opposite. So we would do ECC first and XOR afterwards. So since those are are directly the opposite, that's not a good way to name them. So I've been thinking about another way to get things into a clear name, and that's the idea that I would like to present you now. So here we have several different concepts, and most of them are about coverage. So what is covering something else? Let's take this example. Over here we just have writing requests, so I'm not talking about read here, but I'm just talking about write on this slide. And the first thing we have here is ECC covers clear SA. What does that mean? That means at first the firmware assembles the data area and the SA area. And then there is an ECC, an error correction code, calculated based on the data and based on the service area. But the important point here is the SA area that's being used to calculate the ECC is in clear. It's not XORed. That's the important part on this one. And the ECC is depending on the SA. It's not just depending on the data area, for example. That's the concept called ECC covers clear SA. The next topic would be ECC covers XORed service area. So this time it looks like this when we do a write request. At first the data area and the SA area are created. Then both of them are XORed. So we have XORed data and XORed service area here. And then the ECC is calculated from both the data area that is XORed and from the SA area that is XORed. So that means the ECC here is covering the XORed SA. It's not covering the clear SA that we have over here, but it's covering already XORed service area. The next concept is ECC covers XORed data area. So in this case, it's the same like we had here. But in this case, the important question is the ECC area calculated based on the XORed data area? Or the other alternative would be, if that's not the case, then the ECC would be using clear data area. The assumption that I think we can always assume that ECC, when it's available, and I assume that it will always be available, is covering the data area. Not covering the data area would not make any sense, so that's a pre-assumption that the ECC is covering the data area. The question here is it covering the XOR data area, like it's in this case that we do first XOR and then ECC the calculation? Then the ECC covers the XOR data area. And it has different values in there if it would be from the XOR data area or from the clear data area. So theoretically we would have another concept that would be called ECC covers clear data area, but since that's always the case, I assume that we don't need that as a specific concept to talk about. The next topic here is the XOR covers the ECC. So in this case, it's similar to the variant that we had here. But the question here is the ECC that has been calculated, is that being run through XOR as well, like this? Or is the ECC perhaps not run through XOR like it would be in this example, for example? So if the ECC is later on run through XOR, so on the flash the data that you get is XOR the ECC, then the XOR covers the ECC. Next topic, does the XOR cover the service area? So there are cases, do we have any of them here? No, not on that screen. So there are cases where the service area has been in clear, especially with older pen drives. There the service area has been written in clear to the flash, to the NAND flash. But this concept says that the XOR covers the service area and is then written to NAND flash in an XOR encoded way. And last but not least, there is the concept of a dedicated service area, ECC. So if there is a dedicated service area for data, if there is a dedicated ECC area that's covering only data, and if there is a separate ECC area that's covering only the SA area, then I call that a dedicated SA ECC. That's the idea behind it. Now let's take a look at two examples to make it clear that we are really on the right page. So this time I'm taking a look at both writing first. So the upper part here is what we do when we write it, and at the lower part we take a look at how the process looks like when we're reading it again. So when we are writing it, in this example, let's take a look at the first concept that we've learned before. The ECC covers clear SA. Let's check whether that's the case. So we have here the case of ECC, and as we can see, the service area is being written to the NAND flash directly without being XORed and without being ECC'd. So the ECC, as we can see that there is no arrow over here from the service area to the ECC area, the ECC does not cover clear SA. So we have a definitive no over here. The next concept, ECC covers XORed service area. Here we have the service area, and we can see that there is no XOR over it, and there is also no ECC over it. So this is definitely a no. ECC is not covering the XORed service area. The next question, ECC covers XORed data area. As we can see, the ECC is calculated before the XOR directly on the data itself, on the raw data. So in that case, the ECC covers the raw data, but it does not cover the XOR data. So if the error would be if the ECC error would be going from the XOR to the ECC block here, then that would be a yes. But as we can see, the ECC only covers clear data. Over here we have clear data. Next question, XOR covers ECC. So we have the XOR, and we can see that it only applies to the data area. So only the data area is XORed here. The ECC already has enough entropy, so they decided not to XOR it as well. And therefore we've got a no here. Next question, does the XOR cover the service area? As we can see, the XOR here only covers the data area. It does not cover the service area, therefore we get a no here. And the final question, do we have a dedicated SA ECC area? No, we just have data area, ECC area, SA area, but no dedicated SA area no dedicated ECC for the SA area. SA area is not protected by ECC here, so we could get bit errors in the SA. Now to take a look in the opposite direction from the reading point of view, at first we XOR the data area here, then we do the ECC decoding with the ECC data and the XOR data area, and that gives us the data area, and the SA area has been in clear already. So that's the first scenario that we've taken a look at, and we could now see which answers we get from those concepts, whether they're, so we can see that all of those concepts do not apply to this kind of firmware concept for an NAND flash controller. Now let's take a look at the second example. So this time it looks quite different to the first one. The first question is, does the ECC cover a clear SA? We take it, here is the ECC area that's being generated here. As we can see, the service area that is covered by the ECC, but the service area is already XORed. So it's not a clear service area, otherwise the error would go from here to here. So basically the XOR does not cover the clear service area, but the XORed service area. So we get a no here. Next question, does the ECC cover an XORed service area? Yes. The ECC, as we've seen, covers the XORed service area. Next question, does the ECC cover the XORed data area? We have the ECC, we see that it covers the data area, and we see that the XOR has been transforming the data area before it goes into ECC. So yes, ECC covers the XORed data area. Next question, does the XOR cover ECC? So we can see the XOR is over here, and it's not being input by ECC. The input is only generated afterwards, but not before the XOR in this case. So no, the XOR does not cover ECC. Next question, does the XOR cover the service area? As we can see, the XOR covers the service area. The service area is being XORed and then later on written to the NAND flash. So yes, XOR covers service area in this case. Do we have a dedicated service area, ECC area? No, we don't have that. Okay, that's the second example, and here you can also see the reading again. So in this case, we would do first ECC decoding, and which would give us the ECC decoded data area and service area, and then we would do XOR both on the data area and the SA area to get the clear data at the end. So I hope that the names are clear now that I have defined here. I could not find any industry standard names for those concepts. So to be able to clearly talk about cases, I thought it's really necessary that we define those terms in a clear way and explain it so that we're all on the same page when we're talking about it. And I hope that this is helpful for you to understand it and use it later on. Thank you very much for your attention. If you have any questions or ideas for improvement, please let me know. Thank you very much.